In this video, we're going to be taking a look at this ginormous stack of vintage IBM PCs, starting with the IBM PC itself, the 5150, including the 5160 as well, the PC XT, and moving on to the 5170, otherwise known as the PC AT. I found all of these at eWaste. They're obviously need a lot of help, and I'm hoping that I can get a few of them working. It's going to kick off today with this episode right here on the Retro Hack Shack. All right, well, I've gone handheld already in this episode. Welcome to the Retro Hack Shack. My name's Aaron, by the way. In case this is your first time here, welcome to all of you, and thanks to all my patrons who support the channel. So the other day I was at eWaste and was looking around at the pallets of old computers that they had getting ready to go to scrap when I saw something really interesting. It was a pile that looked something like this. Now, they were stacked a little bit more neatly. I arranged them for the opening a little bit. But yeah, it was a pile of old IBM PCs, and most of them didn't have cases. It looked like they were just parts. Maybe came out of a barn or something. I don't know what happened to the cases. All the ones, usually when you find them, they do have cases because, I mean, what would you do with the cases if you didn't have the rest of it? So let me just go through this stack here and I'll tell you what I've got, and then we'll start breaking this down. And this will probably be a repair-a-thon, although I am thinking about calling this a salvage-a-thon. When you see the condition that these things are in, you will understand why it may not be repairable, some of this stuff. But let me just show you what I've got, and then we'll take a look at them a little bit closer one by one. So up here, it's just a 5160 case. So we've got the exterior case, the outside, and then we've got the main case itself with a power supply. So that's nice to have, because just below that, we've actually got a full 5160 with the guts inside and everything, and it did not have the top case. So I'm thinking maybe I can combine these two if I can get this one working, and we'll at least have one working 5160 out of this group. Down at the bottom here, there are three 5170s. Currently my most hated of the original series that came out from IBM, the PC AT, and I'll go in later into why I don't like them. Three of those that are in various states of being repairable. We'll see about those later on. And then finally down here on the bottom, because it was the only place I could put it, is an actual 5150 motherboard. And I'll actually start with this. We'll see if we can get the motherboard up and running or repair it if there's anything wrong with it. So I'm going to start with the 5150, go in chronological order, back up to the 5160, and then work my way down through the 5170s. It may take several episodes, so I hope you like this stuff. And yeah, stick around for the journey. It'll be a lot of fun. And hopefully at the end of the day, we will have salvaged a bunch of vintage IBM PCs from going to scrap. That's the plan anyway. Let's see how it goes. All right, well, here's where we're going to kick this off. I don't know how many episodes this is going to take, but this is the original. And what I mean by that is this is a 5150 IBM PC motherboard, but it is the original 5150 motherboard. And the reason I know that, so this would have been released probably in 1981. We'll take a look at the date codes in just a minute. But the reason I know that is because of this little marking right over here and the color of the board. So the original color of the board that would have come out, the first run of these things, would have been green. Later 5150s, like the one that I have up in my shelf over there, actually has more of an amber colored or orange coated board, and that was the later revision. But there also is a marker over here for the memory right up here. The memory is 16K to 64K CPU. So I don't know why they put CPU there, but basically that means that this board started with 16K, and you probably could have bought it with a full 64, but most people would have bought it with 16K, and then you can add more memory to get it up to 64K of memory. The next revision that came out after the green boards would have said 64 to 256, I believe, up here. So this was really the original 5150 IBM PC. So really cool to see this. And it actually doesn't look like it's in too bad a shape. Let's go ahead and take a closer look at the board. So this is the way the board would have been put in the case, with the front of the case pointing this way here, and the back of the case pointing that way. Got the power connectors there, and the power supply would be sitting right here. We'll see an example of this when we get into the 5160. But the first thing I notice is this memory here. So it's fully populated with memory. So this should have, if all of these are working, who knows if they are, 64K of memory. It would have come with these. You can see this first bank here is soldered in. There are 8 memory chips here, and then another one for parity, and then that follows with 8 more and so forth in the parity chips down here. So whoever had this either upgraded it or paid to have it upgraded out of the gate, I guess. And then there looks to be one chip down here that has been replaced. These chips, all the other ones are kind of dulled. And then this one appears to be a little bit more modern chip here on the end. So maybe at some point somebody replaced some of the memory here because it had gone bad. And here's a closer look at that memory. The IBM PC came out in late 1981, I believe. And so these chips both have date codes of 1982. All of this memory is Motorola memory, 4116 memory. And actually, I was wrong. This chip over here with the darker plastic was a little bit before this duller finish chip, a different package over here. So this chip is actually older. This memory chip is actually older than all of the other ones, or at least the one right next to it here that I can see the date code on. So yeah, 1982 memory. Let's hope it works. If not, I should have some replacements that we can throw in here. And up here we have a full complement of ROMs that are installed. I will take a look at the date code here in just a second and see which version this is, because there are some issues with the earlier revisions of the BIOS here. And if you have one of those older revisions, you definitely want to replace it with one of the newer 5150 ROMs. But it's good to see that they're all in here. They're not snapping around too much. So looks like this was stored someplace pretty well because the chips haven't worked their way out of the sockets too much. All right, so looking at the ROMs, the one we're interested in is this one right here. And it's difficult for me to see, but I believe that the model number of this one is 5700671. And that is one of the original BIOS ROMs, and that is going to be a problem. The reason that this is a problem is because it won't recognize option ROMs. So if you had, for example, a network card, or in our case, the XT2 IDE ROM that boots and lets you boot up compact flash cards and other things, yeah, that's not going to work on this one. We'll see if we can get it up and running, but probably we'll have to replace this if we want to get anything more than a floppy drive working on this thing. The other limitation that this BIOS has on the system is that it only allows up to about 500 and some odd megs of RAM total to be addressable on the system. So you've got this bank of RAM down here that'll be 64K, and then you could slot in memory cards into the slots here. But unfortunately, if you put like a 1 meg memory card in one of these slots, you wouldn't be able to see all that memory. It may even just error out. I'm not sure with this BIOS in here. You're going to have to upgrade the BIOS to get beyond that 500 and whatever it is, 44 meg limitation that is imposed by this BIOS. Everything looks really clean. There are a lot of tantalums, of course, around the board, and those can short and cause shorts on the board, so I'll be checking those out in a minute. But I did want to point out, if you're not used to working on a 5150, there are 2 connectors back here, and you might be wondering why there's 2 keyboard connectors. Well, they're not both keyboard connectors. One is a keyboard connector, and you have to have an XT compatible keyboard for this. But the other one, in fact, no, I don't remember which side it's on, is a cassette connector. It's a DIN connector to hook up a cassette, because the original boards came with the option of running tapes to load your software, just like a lot of other systems that were around at the time. So it doesn't have 2 keyboard connectors. It has 1 keyboard connector and 1 cassette connector. All right, well, I've broken out my multimeter in continuity mode, and it's time to test the board for shorts. Now, one thing to note, I've gone ahead and pulled up the pinout for this connector because it is a little bit different than a 5170 or even later PCs that you might be used to working with, AT-style PCs that were common right up into the 90s. And that is that the second connector up here from the top is 5 volts. There's a 5 volts. There's 3 5 volts down here, but there's one 5 volt up here. It's the second pin in. However, that was not implemented on the 5150 and 5160. That didn't come in until the 5170. So on 5150 and 5160 boards, this pin right here is not connected to anything. So if I was to go over here, what is normally a 5 volt pin there, which should be connected to these 5 volt pins down here, if I was to go over and touch any of these, you can see there's no connection. That's not connected to anything on the board. Of course, these pins are all tied together because these are three are the 5 volt pins here. So what I want to do first is I want to touch one of these ground pins and then connect to the 12 volt line here. So that's the positive 12 volts and that's the negative 12 volts. So it doesn't appear, maybe there's some capacitors charging there, but no dead shorts. That's what I'm worried about. And then if we go over here and look at the negative 5 volt line, no shorts there. And if we come over and look at the 5 volt line, whoops, I thought I saw something there. It's just barely registering, but it's not anymore. But yeah, there's no dead shorts over here either. Let's switch over and see what that is actually reading. Okay, that value kind of skipped right over. Let's see what that value actually is. Okay, so 265 ohms on the 5 volt line. It's not a dead short, so I'm not worried about that. If that was under 20 ohms or so, which I have seen in the past, then I would be worried. But for this, it looks like that's going to be completely fine. Of course, these tantalums could blow at any time. Once we put this thing under some load, those old tantalums could go. So we need to be careful of that. But right now, it doesn't look like there's anything to be concerned about yet. So keep our fingers crossed. Before I turn this on, I do want to just set my switch settings correctly, at least for what I have in here now. If we hear any beeps at all, that'll be a positive sign. But if we don't hear any beeps, I want to make sure that we don't have the switch settings wrong and we're getting false positives because the system isn't configured correctly. So this should be switch 1 down here towards the middle of the board, and then on the outside of the board, this should be switch 2. For switch 1, the very first switch up here tells how many floppy drives you have. If you have no floppy drives, then switch 1 needs to be on. And right now it's off, so it must have had a floppy drive configured at some point. So turning that on means that the 5150 has no floppy drives. The next switch, switch 2 here, is for the coprocessor. So off means that the coprocessor is installed, and on means the coprocessor is not installed. The coprocessor, not sure if you can see it, but it's right up here, would go right up here above next to the CPU, and it's not there. So I'm guessing it was never there because this switch was never turned on. Okay, switches 3 and 4 are also important because that describes how much memory is installed on this board. And we have all of the memory installed on this board. So if you have all 4 banks populated, all 4 banks of memory, which we do, both 3 and 4 need to be off, and they are. 3 and 4 are off. 5 and 6 are for the video card type. And for now, these really should just be left off because we don't even have a video card in there. And then switches 7 and 8 are for how many floppy drives you have, which doesn't matter because we already flipped this saying that there's no floppy drives attached. But we can take a look and see what was in here when last this was used, which is 7 is off and 8 is on. And that would have been for 2 floppy drives. Now, if you only had 1, would that matter? I don't know. But if definitely if you had more than 2, you would need to set this up differently so that you could address those additional floppy drives. Now, switch 2 up here controls how much total memory the motherboard has. So it's a little bit of a duplicate. This one says how many banks are populated, and this one says how much total memory you have, including expansion memory and things like that. So I can tell you right now that we want all of these to be set on. 1 through 5 are the switches that control that, and the 6, 7, 8 I don't think matter at all. I don't think they're used for anything. But 1 through 5 control how much memory is installed on the system. And we want, for 64K of memory, we want all of them set off. But I do want to look and just see what this was configured for before, which is 1 is on, 2, 3, and 4 is off, and then 5 is on. And that corresponds to a 512K total memory available system. So there would have had to have been, in this particular computer, there would have had to have been an expansion card in here because that's what it's set up for, 512K. And of course, this only has, I believe, 64K of memory on it. So for now, I'm just going to go ahead and flip all of these switches up. Hopefully those are all working and they're not corroded in there or anything. But now we have the system configured for what it should be so that when we apply power, it's looking for the right thing for what is actually installed in the way the system is set up. All right, I've got a spare power supply out. I'm going to go ahead and plug it in here. And do you ever notice that there's these little keyways? I don't know what the best thing to call them is, but they're little keys, little plastic tabs. And when I was working on newer computers, 386s and 486s, these things never lined up, or perhaps they would have these keys on every single thing going across, and you kind of had to play with it a little bit to get it installed. Well, not so in this case. When you go back far enough, it appears in time, the keys actually do line up, and this would potentially, not for sure, but that key lines up, that key lines up, and this would potentially prevent you from putting these things in backwards, which is really bad. You want the grounds in the middle, these black wires, and you could, in theory, switch them around and do some damage to your system. But this is the first time I've ever seen those keys actually line up to where they're supposed to go, except in original systems with original power supplies. Okay, now I believe the power supply that I'm using, I have tested this. In fact, I fixed this. I don't know if I featured this on the channel, but I did mark it. I put a check mark up here and I said it was fixed. This does not go with a 5150 or 5160. I think it was for a clone computer of some sort. It's a DVE power supply, but it should work just fine. But because it's probably a later power supply that does require a load, I'm guessing it was from the AT era, the 5170 era, that required a load or a resistor to be put on to get the power supply to start. I have hooked up an old hard drive. Obviously, we're not going to be hooking this type of hard drive up to this computer, but this should give us enough load to get the power supply started. And hopefully, I've hooked up a speaker, so we should hear some beeps when we get this thing started, and that'll tell us if this thing is actually working or not. I'm not going to put a video card in it yet. We'll do that later, but first I just want to turn it on, see if anything blows up, and see if we get a beep. And I'm just going to give these chips one last press to make sure they're all in there, and they are. They're good. So anything that's in a socket can wiggle its way out over time, and this all looks good. Here we go. Okay, power supply started up. Hard drive is running. Nothing's blown up yet. Fingers crossed. And this could take a while, so we'll probably have to have a dissolve or a little clock wipe going on here. Haven't got any beeps yet. And I'm just doing the old finger test to see if anything's getting hot, like really hot. And so far, nothing is getting hot at all. And just double checking my voltages, I am getting 5 volts, I am getting negative 5 volts, 12 volts, and negative 12 volts. The power rails are stable and working exactly as they should. All right, well, I'm just doing some investigation here. One thing I noticed already is this trimmer pot, which adjusts the color output. You can see it is just broken off completely. The little disc is broken off and it's loosey-goosey. I'm not sure that would keep it from starting or from booting, but that's definitely a problem. So let me go ahead and replace that to get started. All right, here's a closer look at where that trimmer was, and I should say trimmer and not pot, because it wasn't a variable resistor, it was a variable capacitor right here that ranges between 5 picofarad and 30 picofarad. And this is to, like I mentioned, adjust the color signal when you're using composite out on a CGA card, not when you're using the regular digital out, only when you're using the composite out. However, it is in series with the main crystal here. I believe this is the main 4.77 megahertz crystal here. You can see there's already been a tweak done to it over here. But yeah, if this thing was falling apart, then that would have cut off the clock signal to the rest of the board, I believe. All right, you may not be able to see it, but there is a 20 picofarad capacitor in there now where that other 3-legged variable capacitor was. Now let's turn it on and see if we get any further. Hopefully we get a beep here. Well, still no beep, so that was not our problem. There must be something else going on. All right, so the next thing I'm going to do is I'm going to go ahead and take all the chips out that are in sockets and go ahead and apply some deoxit to the sockets. And hopefully if there's any, you know, maybe just a little bit of oxidation or something that's keeping a pin from connecting well with a socket, you know, that might clear it up. The other thing I'm going to do is I'm going to take out all of the socketed RAM and get back to just the bank 0 here. So I'm going to set the dip switches to just the bank 0, and then we'll go ahead and eliminate at least all of these, you know, RAM chips if we have multiple RAM. I think if we had like one, as long as it wasn't this bank 0, I think if we had 1 or 2 bad ones, it wouldn't necessarily keep it from booting, but you never know. Still no beep. I think my speaker's working. These pins are bent though. Let me put some pressure on here just to make sure we are getting a good connection with the speaker. Oh, well, it helps if you plug in the power. Okay, power's plugged in. Let's try it again. I'm hearing the speaker click when the power is turned on, so I assume the speaker's working. We're still not getting any post beeps. Okay, well, it's been a few days and I'm back to this project because I had to get some other stuff done, but I wanted to see where we're at. I mean, all the easy stuff I've done with this board so far hasn't yielded any positive results, I guess. No shorts, deoxed all the chips and put them back in. Took away all the extra memory in case that was an issue. So we're down to, I want to say, more advanced troubleshooting, but pretty typical for this board, right? So we want to go ahead and take a look at a few things on the motherboard. One is, are we getting a clock signal? Is the reset line, you know, being held in a weird way, maybe? Are there any signals on the analog lines here that we can see, or digital lines? Is there anything going on that might indicate a problem that way? I did go ahead, just so you know, I did go ahead and plug in a keyboard and a video card. Nothing, I didn't get anything out of it. So there was no, it's not like the speaker, it's just that the speaker's bad. No, the speaker seems to be working. When I power on the system, I do get a little bloop on the speaker, not a bloop, but well, you know what I mean. If you've done this before, you get kind of a little tick when the power goes through the speaker. This is kind of the part these days that I dread because of the condition of my eyes. But the nice thing about this particular board is the math code processor slot right here doesn't have anything in it. And some of the lines are shared. I believe at least like the clock, the reset lines, some of those things are shared. So I can more easily probe around in this socket than I can risk short-circuiting something on here because I can't see it that well. So I've got my handy-dandy oscilloscope set up over here, so let's go ahead and turn this on and see what we're getting. Okay, the first thing I just want to measure over here is VCC, which I believe should be on this pin. And sure enough, that is 5 volts exactly, like I would expect. I've got a little pinout over here on my phone that I can reference. The second thing that I want to take a look at is the clock. Let's see if there's anything on the clock. That's this pin right here, and we can see that we're getting a good clock. Now, unfortunately, this oscilloscope, well, I love almost everything about it because it's so handy. Like most oscilloscopes, you can't really get a really good frequency until you get dialed in, but it won't give me a good frequency count. But the fact that we're getting something on here is telling me that the clock is probably good. And if I doubt that the clock is right, I can always hook this up to another oscilloscope and check that out. It would be nice to see if this was 4.77 megahertz like it's supposed to be. But for now, it does look like a good clock signal. So we can also check ground, since ground is the pin right next to that. And of course, that is ground. And then I want to check the reset line. Now, the reset line should be this one right there. And right now it is low. And the way this should work is it should go high for about 4 microseconds, I think it is. It's very short, but it'll go high for a certain amount of time while the board is logically setting up some of the chips here to check for power. And then it will go back low, and it will also set the power good to 5 volts. So I'm getting 5 volts on the power good, so I'm assuming that this is all working. If I wasn't, I would definitely go here and check the reset line. But let's just make sure that this is not held in reset. Go ahead and turn this off. And what we're looking for right here is for this yellow line to jump up just for a brief second. I mean, it'll really only be about half a second in visual terms here. Let's see if it does that when I turn this on. Yep, Yep. I don't know if you could see it, but it jumped up and then it dipped back down again. That's exactly what it should be doing. Okay, so there's a few more pins we can take a look at. One is the ready pin, which is, this chip's getting warm. It's not hot. That's kind of a good sign, I think. This chip is a little warm. That's, I think, okay. And the CPU is not cold, but it's not like burning up or anything. Let's take a look at the ready pin, which I believe is this one. And this is interesting because it's not high or low. It's getting this drop here. Let me see if we can drill into that a little bit. Okay. So yeah, it's getting this pulse here. This, I think that's like equates to about 15 microsecond pulse. And I believe that this is the timer that's set on this chip right next to the BIOS. It's I believe it's an 8253. And this could give us an indication of what's going on here. Let's go ahead and take a look at this pin. I think it's like 13, pin 13 on this chip, and see if that is the same signal. No, it's a little different. Well, that's weird. The signal on the ready pin has now changed pretty dramatically from what it was just a minute ago. Let me try turning this off and on again. Yeah, what's going on? This is definitely not the signal that I had a second ago. Well, I hope I got that on camera, because what I should see, I think, on this line is that little dip, that negative dip that goes down, and it's about 15 microseconds long. If I pause this now and we go in here, we're actually seeing more data on here that is not that 15-second dip. So I wonder if things are failing on this board as we go through. Ooh, these resistors are getting really hot down here. Now that I've had this running for a bit, yeah. Okay, I think we're starting to pinpoint a problem, maybe. Yeah, these 4 resistors down here are hot. They're hot. Okay, maybe there's a bad chip here, a bad logic chip or something. All right, well, I looked it up. These resistors seem to have something to do with the cassette mode controlling this relay. And so if these are being held high or low, then yeah, they could be getting kind of warm. So I'm going to set that concern aside for now. Maybe that's just normal for these resistors down here to be getting a little warm. But for now, I want to take a look at the address lines and the data lines. So here, I think this is one of the address lines up here. Let's go ahead and take a look. Oh, look, we're getting activity. Whoop, that's weird. I swear I saw activity there, but now it's stopped. Data lines are down here on this side of the chip. That one's high, that one's low. What the heck? Okay, I don't know if I'm on a data line or I'm right in the middle here. I don't know if I'm on a data line or an address line. Let's just turn this off and turn it back on again and see what we see. Oh yeah, look at that. Oh, okay. So this is actually running code, but it's getting halted somewhere in the post process. Let me go up here and just try another address line. There it goes. Oh, and it's gone. Okay. So this is actually running. That means that the CPU, at least it appears to be good. I think the CPU is good. I think there's a problem somewhere else, and it could be in the memory. Because if memory serves, see what I did there? If memory serves, perhaps the BIOS is starting to run and testing this first 16K of memory. And if this memory's bad, then it would halt the CPU. And we all know that memory of this era is prone to go bad, even though these aren't, bad chips necessarily. They're Motorola chips, but it doesn't matter. They can go bad. So now I'm wondering if the memory's bad. So there is a way I could take this BIOS chip out, and there's a diagnostic BIOS, I think, that will run even if the first 16K of memory is bad. Let me go see if I can find that, and maybe we can run that and see if maybe just one of these memory chips is bad. These are soldered to the board, so I have to desolder them, which, isn't always fun. I don't want to damage the board, but maybe that's our problem right there. Maybe that's our problem. Okay, well, I'm back with my brand new diagnostic chip. So this is RUUD's, R-U-U-D, RUUD's Diagnostic, and the fact that it has a double U in there makes it easy to look up on a Google search or something. But this is available in different versions. It's got everything built into the ROM, so it should be able to tell us if we have a memory problem, where that memory problem is. And the other thing that this will do is it will tell us if we have a bad BIOS, because that's the other problem that could happen, is the BIOS is corrupted somehow. And so it could possibly be getting to a certain point in the execution in the actual BIOS and running into a corrupted BIOS and just kind of halt at that point. I'm also using this little adapter here. I took some pictures of this so you can get some high quality screenshots because this particular adapter is configurable. So you can configure it to emulate different older style ROM chips that were used in some of these older machines. I'm using a 27C64, which should give me 8K of ROM space, and I've already loaded the RUUD's ROM onto this, but I did have to go in and solder these jumpers on this particular adapter to get it in the right configuration. So hopefully it is in the right configuration now. And let's see if we can get this in the right way. And nope, I got the pins misaligned. I always have to double check with my eyes these days. Ooh, oh no, these are crappy pins. When I pulled it out to readjust it, 3 of them broke off. All right, well, fortunately, I bought several of these. I thought that was my only one, but I had bought several, as I usually do, just in case. But I'm going to have to be really careful to make sure I get these pins lined up because I don't want them breaking off. Okay, it appears as though I've got that in correctly now. So if I turn this on, I think we'll hear at least some beeps and maybe a click of the cassette relay, and that'll tell us something, and that'll at least be progress. Here we go. Yes, yes, exactly. Yes, 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 yes. The diagnostic is working. So that's good. That tells us that the problem is probably in the memory or something. Now, of course, we're not seeing anything on the screen. Let me go see. This particular diagnostic needs a CGA or an MGA card to work correctly because it uses some of the memory off that card to run for some of the tests or something. So I need to see if I can get a display adapter. Maybe we'll finally get something on the screen for this 5150 motherboard. All right, I've gone ahead and hooked up the RGB to HDMI that I sell on my website, of course. Thank you to so many of you who have purchased this. It does help support the channel, and I'm glad I can get it out there for the community. But I've got the RGB to HDMI set up for Hercules mode. May have to set it for MDA mode. I'm not sure how it's going to look, but let's just see if we get anything on screen when I turn the computer on. Here we go. Yeah, so it's seeing something on the RGB to HDMI, but it's not getting a good sync here. All right, well, I found another similar card. It says made in Taiwan. Looks like a CGA card. It's got the monochrome output, or the, not the monochrome output, the composite output, RCA output there. Looks like a CGA card, but I don't know. Let's see if it works. This is working. There we go. CPU passed. ROM checksum passed. Timer channel passed. This is great. I've never used this before. Look at all these checks it's doing. And it's doing it really well. And yes, here we go. Critical error. Diagnosis has been stopped in the first 2K of RAM. So it's telling me that there was bad bits in bit 6 here. So chip 6 might be bad out of the other ones. And it says this may or may not be RAM chips. So yeah, there could be logic chips or something else going on. And this is actually telling me, I believe, the chip number. If we count from the bottom, not including the parity, we have 0, 1, 2, 3, 4, 5, 6, 7. So this chip right here on the board is telling me is the bad one. We'll see if that's accurate or not. I'll go ahead and get that chip out of there and we'll replace it. Or maybe we could even piggyback with one of these other chips that I pulled out of the board and just see if that diagnostic changes. All right, I've got the chip on here. I think the legs are tight enough to make this work. Let's see if we get anything different at this point. It's the kind of chip that has the legs on the end are kind of cut in half, if you know what I mean. And it's kind of a shortened chip. And now it still says there's something wrong with memory here. So something in the memory circuit or in the memory itself is bad. I'm going to go ahead and I think what I'll probably do for simplicity's sake is I'm going to go through and just socket all of this first bank of memory. And that way, if there's more than one bad chip or whatever, we can play around with that and figure it out a lot easier. So I will be back after I've done all that work. Now, just a couple of warnings if you're thinking about taking on a project like this yourself. The quality of these old boards can vary quite a bit in terms of the quality of the solder mask as well as the quality of the traces themselves. In this case, the solder mask on this particular board is quite delicate. I don't know if that's due to age or perhaps it was always like that, but that is not the greatest. The traces look okay, but this is a multi-layer board and it seems to have a huge ground plane. So desoldering chips like this can be a real pain in the butt. So I'm going to be extremely careful and take extra steps to try to get these chips off as best I can without damaging the board. So the first thing I'm going to do is put extra solder on every pin before I attempt to desolder the chip. Because this is a multi-layer board, it's going to require higher heat than normal, which can damage pads very easily. So I'm going to be careful with my desoldering gun not to move it back and forth and all around too much with the wiggle, 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 because that can take a pad right off the board. Another thing to keep in mind is that when these chips were put in, their pins were probably bent to hold them in place. And so you may have to get the tip of your desoldering gun at an angle to actually get it in there and make contact with the old solder. And this can lead to more damage on the board. So again, you need to be really careful here. In addition, I'm going to be using my phone and a microscope, as you'll see in a minute, to take a really close look after I have attempted to desolder the underside of these chips. I want to make sure that there is a clear, black, empty hole all the way around the pin, and if there's not, I'll apply fresh solder and desolder again until I don't see any solder on this side of the board around those pins. Last but not least, I will be using hot air on this particular board to finish taking these chips off. And again, I'm using high heat. I want to be careful to warm up the surrounding area around each chip before I actually go in and really concentrate on those pins. That'll be less shock. And also, I'm going to be very delicate when I'm taking these chips off the board, putting just a very minute amount of pressure on each chip to see if it's loose yet, because it could be very easy to take a pad or a trace off if you don't make sure that that solder is completely melted before you actually lift the chip off the board. As you can imagine, trying to do this with one eye and no depth perception is no easy task. As luck would have it, earlier that day, I received a package from TOMLOV as they had asked me to do some testing on one of their latest microscopes. To be clear, they did not ask me to do a review video, so this is not that. But since it was at the front door, I went and grabbed it to see if it could help me remove these chips and make sure I wasn't damaging the board. In case you're wondering, this is the TOMLOV Tri-L 110. The Tri-L stands for 3 lenses. They have a 1000x lens, a 1500x lens, and a 2500x lens that you can use for microscope slides. I've owned 3 of these things at this point, and the thing I really like about this one is it has a 10-inch IPS screen so that I can see things really clearly. In fact, sometimes I almost felt myself pulling back a little bit because things were so magnified and so clear. It also has a 24 megapixel camera and HDMI output up to 1080p, I believe, or maybe even 2K. And this is really helpful if my eyes end up getting worse. I could put this on an even bigger screen, like this big monitor that I have that's mounted to the roof of my garage and comes down like this. I can definitely see every bit of this image on that screen. And this thing really saved my bacon too. Here's an example of some of the video I recorded from it that I took so that I could go back later on in case there was a problem. And you guessed it, there was a problem, and I did have to go back to this video to see what the problem might be. So even though I didn't promise any sort of reviews or mentions for them sending me this product, I did want to include it here because it was such an important tool for me, at least on this project. And if you have trouble with your eyes or you're doing a lot of SMD work like I do as well, then you might want to consider picking one of these up. I will go ahead and throw an affiliate link down in the description that you can use to get one of these, and that'll help support the channel. And thanks to TOMLOV for sending this microscope my way. It really did help. All right, well, there it is. I've got everything back together. I've got all the sockets in. That was an ordeal for sure. Really wanted to be careful with this board, especially since it's the original IBM 16 to 64K board. I almost said megabytes there. But yeah, I just wanted to be careful and protect as much as possible. That microscope really did save my bacon. I mean, I hope it won't be a problem, but I did find two areas of concern. One was a trace that looked like it was bent in a V. I don't know if it was completely broken, but I would have never seen that with the naked eye. But I was able to see it on the microscope, and I was actually able to push it a little bit with my small screwdriver and then solder it back into, put some solder over it to stiffen it. And I did continuity tests on it, and it tests okay now. And then there was another pad that it looked like it was lifting, like I had pulled it a little too soon. It looked like it was lifting up, but it wasn't disconnected from anything. I put the socket in, and again, I did continuity on it, and it is testing okay. So we will believe the continuity tests on this. I did inadvertently melt a little bit or warp one of these sockets here where the cassette ROMs go, these four here. So hopefully that'll be okay. I thought that while I have everything out of this, the cassette ROMs and all of the RAM, I thought we would test RUUD's Diagnostic again, just to see if it actually works with nothing in it. Okay, well, yeah, it is actually firing up and working. So good to know. I didn't know if that would work with nothing else in it, but no, absolutely no RAM in this thing, no cassette ROMs, only the diagnostic ROM. And this is interesting too. This tells us something that before it was saying either 6 or 5 was bad. I think it was 6. And now it's saying that all of them are bad. So it really is, or seemingly, narrowing down when it could be a problem on one specific RAM chip. That's really nice to know. All right, I'm going to power it down and populate the RAM. We'll fire it up again. Okay, all the RAM is in there. I've moved the suspected bad chip up to the 7th position up here. And from 0 to 7, I guess it's the 8th position, or 9th if you include the parity. But it's in the last position, not in the 6th position. But let's just go ahead and see what we have now. Oh, that's not good. So this says that all of the RAM chips are still bad. So it could be that I ruined all those chips. I'm going to take these out, put in another set, and we'll see what happens. Now, one thing about this memory I took out, this is the memory that was soldered into the board over here. This is the memory that was in the socket over here. And you can see that the ones that I took out, that I desoldered, look like they have been trimmed with trimmers. And so the reason this may actually not be bad memory, but it may just not be going into the socket enough to make a good connection, or every pin might not be going into the socket far enough to make a good connection. So that's also a possibility here. But for now, I've put another row of memory that I pulled out of these sockets over here in the first bank. And let's see what happens. And it's saying they're all bad again. So I don't think that's possible. So did I damage something when I was soldering? There's something definitely wrong at this point. So I'm going to have to get in here and do some more digging, I guess. All right, time for an update. I've got the diagnostic running, and it's halted its tests, and it's saying that everything is bad about the memory. It's just bad. Let's zoom in here, and I'm going to show you what I've done so far in terms of troubleshooting. All right, so of course the first thing I did was I examined all of the backside of the board and tested for shorts between, ground and the voltage levels. And I also went through and I tested for shorts on every address line, basically every single line that I could, even all the data lines, even though this seems like it's a problem that's affecting everything on here. So I'm not suspecting a data line. A bad data line would indicate one bit that was bad, not the whole thing, right? So voltages seem good. Nothing seems shorted either to ground or to any of the voltage rails. But, if there's an address line or something that is either shorted, or maybe two address lines, a blob of solder got in there and the address lines are competing, that's going to affect every chip on the board, right? Because all those address lines are tied together between all these chips. So I started just going ahead and taking a look at some of the different address lines and things, and we can see here's an address line. It has normal looking activity. Here's another address line, again, normal looking activity. And I tested all the address lines look like that. And then I tested the data line. The data line isn't doing anything right now, but if I was to reset the board, in fact, let's do that. We'll see that there is activity on the data line, this particular data line anyway. Okay, so the system's coming up and you'll see, there we go. We've got data coming in on the data line. It looks normal. It doesn't look like it's getting pulled high or low or anything like that. And then I was looking at the RAS and the CAS. Now here's the RAS, and you can see the RAS is getting this pulse, right? So this is the row selector, and it's getting this pulse, and then the CAS is on the other side. And what I'm seeing on the CAS is nothing. Nothing on the CAS at all. And this took me down a rabbit hole for a while, but then I realized that the diagnostic test is halted, so maybe there is a pulse on the CAS on this particular bank of memory in the beginning, and then there's nothing, because that's the way the diagnostic works. So if I set my trigger level here to normal and we go ahead and reset, okay, hopefully you can see this over here, but it should trigger again, because what I found is that it actually was working when it goes to read the memory. Now it's just about to read the memory. There it goes. So there is some activity on the CAS line when it goes to run that test on the memory, but then there's nothing after that. It just does that and then there's nothing. So it just halts like that. So I think what I'm going to do now is put the regular BIOS back in and see if there's constant activity on the CAS line without the diagnostic running. All right, so I'm on the CAS line, and yeah, there's plenty of activity on the CAS line. So it's just the diagnostic that stopped, and that kind of threw me into a different direction. So I'm still assuming that I did something. Maybe I dropped a blob of solder on the board somewhere. I just don't know where. I'm just trying to find out where to look right now and what is causing that whole bank of memory not to work suddenly after I put those sockets in. Okay, well, I'm pretty sure that this board is cursed, because I'm looking into what could possibly be causing the diagnostic can fail on the memory. One of the things I wanted to rule out, even though it's very unlikely, is that all the memory is actually bad somehow. I don't think that's the case, but let's rule out. It's low-hanging fruit, easy to test, and I've got a Chip Tester Pro here, so I can put in the memory chips and just test them and see if they work or not. Well, now every single memory chip, no matter which one it is, I put in the Chip Tester Pro, is failing. Some of them test. This one's starting to test. Oh, no. They get to different points and then they fail. And these are all tested good. That's why they have a little dot on them like this, or is because I've tested these already. So I know that these either are good or at least were good the last time I tested them, which was in the last year or so. So now the only thing now I think there's something wrong with the Chip Tester Pro. I swear it's like this came in contact with the motherboard and got infected somehow or something. So now either this ZIF socket is bad, which I have cleaned it up by putting in some deoxit and moving the chip back and forth side to side like this, while kind of halfway pressing down on the lever to get it to kind of scrape against it. And it doesn't matter. It still tests bad. Every chip still tests bad. This one's going to go through 2 passes. No, it gets halfway through the 3rd pass and then fails. This is annoying. All right, so I was just about to desolder the ZIF socket on the Chip Tester Pro, but look how dirty the connections are down here. The solder, I think when I put this together, because I did this all by hand, I got a board, got all the parts myself and put it together, and I think I forgot the last step, which is to wash the board. I'm wondering if those salts that have accumulated down here on these pins and the leftover flux, I wonder if that potentially is what's causing the chip tester to fail on those memory chips. I'm going to clean this up and we'll see if that makes any difference. All right, we're back from the bath, which is just my sink, and this is just about dry, and you can see it looks much better. All those pins are nice and shiny. There's no more salts and things around them. So yeah, the whole board is cleaned up now. So what I used was this, something I keep around for heavy duty jobs. It's flux remover, professional MG chemical flux remover. This works pretty well. So if you just have like 1 or 2 things that you're making, let's say, and you want to clean flux off, I don't think it's worth buying this stuff. It's kind of expensive. But to keep it around for me for heavy jobs like this, I do like it and it does work pretty well. Otherwise, I would just, if this was smaller, I would just put it in my ultrasonic cleaner. I have some chemical there that I use on all of my RGB to HDMI boards to clean those up so that those are nice and shiny and clean when you get them, when you order them. But yeah, in a pinch, this stuff will work if you can afford it. 4140A MG Chemical. All right, this should be dry enough to test now. Let's see if it makes any difference at all. With the way this project is going, I highly doubt it. We'll select common DRAMs 4116 and hit test. Nope, fails immediately. Dang it, why? It's got to be this socket here, because not all of these can fail, right? This is failing immediately, right? So you'd expect it to fail the same way every time. But if I move it around or press down on it a little bit with a little bit of pressure, it'll like make it further in the process. Let's put in another one. So this is one of those less shiny or dull chips. Put that in, test that. It fails immediately. If I push down on it, no. It's failing, and it's failing with different... There's no way all these chips can be bad. I just don't believe it. All right, well, I got this to pass. I decided to measure the voltages before I completely gave up on this. What I'm doing is I'm sticking my probes down. The way that this thing with zip socket works is it's kind of like a shutter. These two flaps come together like this. And what I'm doing is I'm putting my probes on the outside of those flaps to measure them, but that has the additional side effect of putting more pressure of the flaps against the pins. And so I was measuring the voltages here, and when I hit test, and while I'm putting more pressure on the voltage pins, guess what? This thing goes through. Not only is the voltage good, the -5 I happen to be on at this point, but it makes it all the way through, and it passes. So I think it is the connection, some sort of connection problem. I'm going to order a new ZIF socket, and in the meantime, I have a feeling it's this ground pin up here. I will just continue to do what I'm doing, which is to use this sharp probe, put a little bit more pressure on that, and see if I can get through all of these RAM chips. But this is one of the ones that I desoldered from the board, the ones that I was a little bit worried because I put so much heat into them that I might have damaged them. This one has passed now about 5 times. So it is a good RAM chip. Well, I did finally, using that method and trying to bend that one ground pin a little bit, I finally got through all the RAM, and guess what? It all tests good except for the chip that was in that number 6, I think that's what it was originally that was failing. That one never tested good. So I've marked that one with an X. That one's bad. Every single other RAM chip on here tested good. So I've got to figure out how to make my Chip Tester Pro more consistent. But anyway, past that hurdle, all this RAM I know is good, but again, we've got bad bits on every channel. So something is still wrong with this thing. So now onto my other supposed low-hanging fruit. I thought that the memory would be. The other one is the dip switches themselves. I'm going to put some deoxit on those and exercise them a bunch of times, because sometimes those dip switches can get corroded or whatever. They can have contact problems. So that's my next low-hanging fruit problem, and I'll be back to tell you if that worked. All right, folks, well, triple checking my work, it looks like I have found a possible, very small problem that is causing this not to work. So what I was doing was I noticed that this trace runs right down in between the sockets here. So these 2 rows here make up a socket. This is the next socket. They're really close to each other. And I noticed that this trace here, the solder mask is really thin. And when I desoldered the chips that were in here before, you can see that a lot of that green solder mask has come off here. And so what I was doing was I was just going through and making sure that everything was connected that was supposed to be connected. So for example, from here, from this little via here to this pin, over to this pin, that all should be connected. I was looking for like really minor breaks that may have occurred while I was desoldering. And then I was also going through and testing all the other pins that were close by, making sure that none of them were connected to this trace. And when I got up to this one right here, I went through that same procedure. And when I got to here, of course, that's connected. But then this is also connected, and it shouldn't be. Let's zoom in on that right there. And I mean, it is the most minuscule amount of solder possible, but it's right there it's creating a bridge on this pin. And this is no doubt an address line. And this other pin over here, I'd have to flip it over and check. I think that might be a data line. So what's happening here is I'm getting a data line that's connected to one of the address lines, and the address line is connected to all the other address lines on all the other chips on that same pin. So if that's the case, then basically I've corrupted the data, that one data line, and all the address lines that are in the same position as this on all the other chips, and that's why they're all reading bad. So I'm going to clean this up, and we'll see if that is what is causing this. But first, I'm going to go ahead and double check all the rest of the pins that I haven't checked already and make sure that there's no other issues like that on the board. Okay, here we go. Fingers crossed. Hopefully that was it. And once we get past the RAM test on this, it's going to go through and probably halt because it doesn't see any RAM in the next slot here. Oh, look, it got past it. I think, yes, it did. It got past it. So I don't know if it's going to test the other banks and halt on those banks, or there should be a lot more diagnostic tests that it does. But this is good. We got past the problem. We got past this problem. Okay, it got through and it's looping around now. So there's a couple of things that failed, but they're normal. I don't have a keyboard connected, so it says keyboard response to reset failed. Of course. Reset floppy controller failed. Of course. There's no floppy controller connected. Check ROM F4000 failed. I believe that one is the empty one, U28 or whatever. That's pretty much always empty. I'm not sure you can use it really for anything. And then the other ROMs passed. And then, and it also tells you the state of the switches. So the state of switch 1, the state of switch 2. It goes out and reads them. And so that matches what I have the switches for. So, and then this is not an XT, so it doesn't have the XT switch. So everything else passed. This should be now a working 5150. We fixed it. We fixed it after days of work on this thing. It looks like it's finally working. All right. Let me hook up another video card and see if we can get this thing to boot or do something. But this is completely working at this point. It is completely working. Okay, well, I've gone ahead and put all the memory in here, and I ran RUUD's Diagnostic again, and yes, all the memory does test okay. So it was really just that one chip all along, and the other stuff was rabbit holes and like the weird little solder blob that was barely touching that caused the whole problem. I did go ahead and set the memory dip switches back, by the way, for the diagnostic to work on all the memory. You set the dip switches back and it will go ahead and run through the entire set of memory, however many you have it set up for on the switches. So now what I want to do is I've put in the original BIOS back, this is the second edition, the one that doesn't support option ROMs. Let's go ahead and turn it on, and hopefully we hear some beeps. We should hear some bad beeps going on because we don't have a keyboard plugged in, we don't have any floppy drive controllers plugged in, no hard drive, etc., etc. So let's see if we get those beeps. Should take about 5 seconds or so. Yep. Very unhappy 5150, but working 5150. So now, in order to test this thing out, we need to, well, there's a couple things we could do. Obviously, you could hook up a whole system here with floppy controllers and hard drives and stuff. I don't want to go to that extent, but I did pull out my XT to IDE adapter here. And in order to get that work, like I mentioned, you're going to have to upgrade the BIOS. So I went ahead and created a 5150 BIOS. This is the third, well, technically fourth, but let's just call it the third major revision that was actually around. And this is the one that you want if you want to go ahead and run option BIOSes like are present on the XT to IDE, or a network card that has an option BIOS, or a video card that has an option BIOS like an EGA card would. In fact, I'll go ahead and hook up the EGA card as well so that we can look at the graphics and maybe use a game as a test for this thing. All right, I've got the updated late edition BIOS, EGA card, XT to IDE card, and I've hooked up my modern neo retro keyboard, and that's hooked up to this new product that I'm selling on the website. If you haven't seen it, it's called the Hidman. I did a video on that. Go check that out if you're interested. But this does support XT mode, which is required to hook up into a 5150 and 5160 XT PC, as the 5160 is known. Here we go. Now, if things really weren't working, I would expect to hear a series of bad beeps after about 5 seconds, and I'm not hearing them. Keyboard does have a light on it. Getting a cursor. That's good. 301. Now, sometimes I believe that's the keyboard error, and sometimes I still get a 301 even with the Hitman. And here we go. So yes, we're booting. We're booting. We're booting into the C drive that's on the CF card over here on my XT to IDE. It's going to take a while because this thing is slow, but I believe this should boot up DOS 5.0. Well, it's not booting up at all, and I'm not even sure. That may be because the limited amount of RAM. We're going to be limited in what programs we can run, and even we may be out of memory trying to load this version of DOS. All right, well, now I've installed, instead of getting a different version of DOS, I decided to try just going to my grab bag of cards over there and getting out a memory card. That way we should be able to add enough RAM to the system to get this up and running. So this particular board has 4164 memory on it. It has 6 banks. And so that's going to give us a total of 384K additional that we can add to the 64K that's on the board. I've gone ahead and changed the jumpers to be for 448K, I think, total amount of memory. So that's on switch 2 up here. The other thing I don't know about this card, though, it is a multi-function card. So it also has a serial port, a parallel port, a game port, and I think a real-time clock. So if any of those conflict with the other cards, if any of those IO addresses or whatever conflict, then that may cause some problems. But I'm going to have my fingers crossed that A, all this memory is working enough to at least get past the initial boot up test, and B, that it's not going to conflict with the other cards. Okay. Enough talking. Let's see if we can actually get to a DOS prompt. All right, well, no initial beeps. Okay, here's the prompt. Now, I believe it's doing the memory test in this stage of the BIOS startup sequence. So it's going out and at least checking, I think, that all this memory exists. I don't know. I don't think it does like a really in-depth bit comparison test where it's flipping zeros and ones. Maybe it does. I don't know. But it should take longer than the other boot up that we did. I'm just hoping it's not hung up here. It's going to take a while if it's going to go check and make sure. Okay, there we go. So it did. Okay, we're booting up. So yeah, it went ahead and it took longer because it was checking all this memory, making sure it was there. And then now there we go. We're booting from C. It doesn't say what DOS version it is. Version 5. So I wasn't sure if version DOS 5 would run on this much memory even. I thought it might even take more than that. But I guess it will run at least to some degree on a system with 448K of memory. So that's good. Now we can go in and see if something runs. Hey, there we go. Alley Cat up and running. Sounds great. Do you want to use a joystick? No. Please select your skill level. Definitely kitten. Press any key to start. Here we go. There we go. Can jump up. Ah, yeah. This is totally working. Oops. Gotta get out of the way of that guy. I want to jump over on that other can. There we go. Oh, I got it, but I jumped off. Anyway, totally cool. Alley Cat's working. Let's try something else. Here's Arkanoid. Let's see if that'll run. We've got an EGA card. Looks like it detected it okay. We're going to use the keyboard. Oh, that doesn't look right, but that looks okay. Yay. Let's see how well this runs on a 5150. Not bad. It's hard to control, of course, with the keyboard, but yeah, this is, what the laser? Ah. Yeah, totally working. So, not totally. We're getting some issues. May have some bad memory. It's easier when you run this slow. But I'm wondering if there's some bad memory on the expansion card here, or something that's causing that corruption. Because it's probably using that memory for the video memory, and I'm wondering if there's a bad chip or something on here. So anyway, this is, we're not going to go any further with this. This board is a success. It's working. It can be used to replace a bad motherboard in some other system. I'm just glad we got it back to life. Whoever dropped this off at eWaste and gave up on it, maybe just got frustrated like I did and gave up. As I almost did, because I was so discouraged that I couldn't figure out what that problem was and went down so many rabbit holes. And yet in the end, you know, we got it and it's working. So I've got to send a big shout out to -0degrees.net, the website that has all the information about these early IBM PCs. I've got about 10 tabs from there open on my computer in my study right now, when I was trying to sort out that memory problem, trying to go back, look at the manuals, look at the information there. Huge shout out to, I forget what he goes by on VC-Fed, Mode 7 or something like that, Modern 7, I can't remember, but huge shout out to him. And he maintains this whenever he solves a problem or whenever he finds a potential problem to a potential issue on one of these boards, he maintains it in a kind of a spreadsheet form. And it's really helpful. You can go in there and look and see what the symptom is and what the potential solutions were. So if you know a little bit about the architecture and how it works, it's like, oh yeah, I didn't think about perhaps this logic chip could cause that particular problem that I'm seeing. And then you can go reference the discussion in the forums about it and see what led to that, you know, discovery of why that was happening. Super, super useful across the board, hands down, best resource for working on 5150, 5160, 5170 systems is that website. So go check it out. Now, I was planning on, I thought this was going to be a really quick repair, which is why I started with looking at all that hardware. I thought this was going to be a super easy one, maybe replace some RAM and jump right into the 5160, but this went way longer than I anticipated. So I'm going to cut the video here, and then next time we'll jump into that 5160 and see if there's anything salvageable on it. I know that it has some bent cards, for example, in there. That thing got like brutally dropped off a truck or something, and it may not be recoverable at all, but we're going to give it the old college try. If you want to see more videos like this about IBM repair and things like that, you can check out the video that I'm going to put over in the corner right now, and I'll see you over there in that video next. Thanks everybody for watching and supporting the channel. Bye-bye.
End of line.